Alright, so we have one more example here involving pressures and static fluids and manometers and such. Here we have a completely closed tube. You can't put liquid in or out. And up here we have point A. We have point A here, and it's water. It goes down here, and it changes to an unknown liquid, which is in the red, and it goes back to water, and it's all the way down here. Now the height from A to B is 1.3 meters. Okay, and this height here, from the water and the unknown liquid here down to here, is 0.6 meters, and this distance right here from the unknown liquid here to point A is 0.5 meters. Okay, and the specific gravity of this unknown liquid is given to be 2.6. And what they want, the question is asking for what is the pressure of A minus the pressure of B. What's that equal to? What's this quantity equal to? And a couple things to note here. The specific weight of water is 9,800 Newton meter cubed. Okay. And to start off, let's set our datum here at point A. Okay, that's like our 0. That's our 0 point. That's our starting point, and we'll keep that throughout the problem to stay consistent. So let's do a pressure analysis from. Let's do. Let me do it in a different color. Let's do from. Oh, we need to make our points. Oh, we forgot to make our points. So here's our path, which we'll go. We'll start at A. We'll go down here, and we'll change liquids here. And we'll call this point, point 1. Okay? And we'll go through the tube, we'll come up here. We change from unknown liquid to water again. We'll call that point 2. And we're going, and we come down here to B, point B. Okay? So let's start at A, at our datum, at 0. Let's go down to point 1. So let's do an analysis from point A to point 1. Okay? And our equation is as follows. Delta P is equal to negative gamma delta H. Okay? Simple. So our final pressure minus our initial pressure. We started at A, we ended at 1. So P1 minus PA is equal to negative gamma of water, which is up here, 9,800 Newton meter cubed, times the height. Okay, so our datum is here. Our final height is from point A to point 1, which is 0.5 plus 0.6, which is 1.1. But remember, our 0 is here, so we're going down. We're going a negative distance of 1.1. So negative 1.1 minus the initial height. Well, the initial height was 0, right? We started at A. We started at the 0 point. Okay? So the pressure at 1, let's add PA to this side. We'll get negative 9,800 times negative 1.1 plus PA. So our pressure at 1 is equal to 10,780. Well, there's a car outside honking. Okay, plus pressure at A. So that's the pressure here. Okay. Now let's go from the pressure. Let's change our camera a bit. Let's go from the pressure at 1 to the pressure at 2. Let's do an analysis there. So our equation is delta P is equal to negative gamma delta H. So our change in pressure will be P2 minus P1 is equal to, right, from 1 to 2, we're traveling actually through the liquid now, the unknown liquid. So we'll say P2 minus P1 equals negative gamma U for specific weight of the unknown liquid. And that's equal to the change in height. Okay, So our change in height, starting from our, what was our initial, or what was our, or let's do height final minus height initial, right? That's the change in height. So our final height is up here at 2, which is negative 0.5, 0.5, minus our initial height. It was 0.5, 0.6, 1.1 in the negative, so negative 1.1. Okay? And this should give us P2 minus P1 is equal to negative gamma U times, well, we can say gamma of U, hold on. So we have pressure at 2 minus pressure at 1 is equal to, if I rewrote this twice, all this, bad me. And that's equal to negative 25, oh, sorry, I forgot a little side note here. This should be equal to negative 25, 480 times this, which is 0.6. Now, how did we get this 25, 480? Well, that's our gamma of the unknown liquid. And up here we said specific gravity is equal to 2.6. And we know that's equal to the gamma of the unknown liquid times water, which is up here, 9,800. And we multiply by 9,800, we get gamma of U is equal to this number right here. Okay? So that number right there times 0.6 negative, we get pressure at 2 is equal to negative 15,288 plus the pressure at 1. Okay? Now I'll continue this problem actually in the next video. We'll do pressure at 2 and go to B.